Recent military conflicts in West Asia have caused massive disruptions to global crude oil and energy supply chains. For India, that global bottleneck translates immediately into a local shortage of liquid petroleum gas, the primary fuel keeping the nation's stoves running. With official supplies drying up, desperate families are being pushed into the black market, where a single cylinder of cooking gas is now selling for upwards of 3,000 to 4,000 rupees just to cook dinner. A geopolitical conflict thousands of miles away has directly compromised the daily food security of millions. Indian households are being forced into a rapid, unplanned shift in how they survive. The immediate consumer response to this crisis is bypassing gas entirely and plugging directly into the wall with electric cooktops. This chart visualizes consumer demand on e-commerce platforms like Amazon India. It shows an 18-fold spike in sales for induction cooktops compared to flat pre-war levels. The government is actively encouraging this pivot. Ministries are currently holding discussions to figure out how to rapidly scale up the domestic production of electric heaters to meet the surge. Plugging a stove into a socket solves the immediate fuel crisis for a household, but bringing millions of new, high-wattage appliances online simultaneously is setting a dangerous infrastructural trap for the upcoming summer. The most efficient way to manage this electric shift is the induction cooktop. From an engineering perspective, it is the gold standard of electric alternatives. It completely skips traditional heat transfer. Instead of relying on combustion to create an open flame, the stove uses electricity to generate a rapidly changing electromagnetic field right beneath the glass surface. When a metal pan enters that magnetic field, the pan's electrical resistance creates intense friction. It converts the kinetic energy of the moving electrons directly into thermal heat inside the metal itself, operating at an incredibly high 85 to 95% efficiency. But induction only responds to ferromagnetic cookware, materials with specific magnetic properties, like cast iron or magnetic stainless steel. Those compatible pots and pans are expensive. For families looking for a temporary fix to the gas shortage, replacing their entire kitchen set is not an option. The most efficient technology is largely locked out of the crisis response. This cost barrier is driving the public toward a cheaper, universally compatible alternative, the infrared cooktop, which is experiencing its own massive four-fold jump in sales. The mechanics here are simpler. Electricity heats a submerged coil or halogen element until it glows red. This emits invisible radiant heat to warm any type of vessel sitting above it, whether it's steel, aluminum, glass, or ceramic. Because the energy is generated in the coil, transferred to the glass, and then finally absorbed by the vessel, a significant amount of heat dissipates into the surrounding air. The efficiency drops to about 70 to 80%. The structural problem with these stoves lies in how they manage their low heat settings. They rely on a mechanism called phase angle control. Instead of steadily lowering the power output, phase angle control rapidly switches the coil's electricity completely on and then completely off in short stuttering bursts. This start and stop method lets a pot simmer cheaply, but it introduces a hidden, highly destructive flaw into the electrical current itself. The rapid on and off switching violently distorts the shape of the electrical current's waveform. This degrades what engineers call the power factor. Because the current is distorted, the local power grid has to push extra compensating current into the home's circuit just to keep the appliance running. That extra current produces exactly zero useful heat for cooking. It merely sloshes back and forth inside the circuit, generating invisible waste. If thousands of people use infrared cooktops, the utility grid is forced to work significantly harder and leak more power just to deliver the same amount of cooking heat. Household electricity use for cooking is incredibly synchronized. People fire up their stoves simultaneously in highly concentrated morning and evening hours. The Energy and Resource Institute estimates this massive shift will hit the grid with a sudden 3 to 5 gigawatt spike right when the system is already at peak daily load. The danger is intensely localized. If just one cluster of homes in a single neighborhood all turn on these distorted infrared appliances at 7 p.m., the demand in that specific pocket skyrockets. This sudden injection of dirty, inefficient load overwhelms local distribution transformers, pushing the neighborhood infrastructure to failure and causing localized blackouts. A hotter than normal summer is already approaching, which means soaring air conditioning use. To prevent the grid from collapsing entirely, the government will have to run its coal plants at absolute maximum capacity. Solving the fuel crisis at the stove only works if the grid behind the wall is rebuilt to handle the load. A genuine energy transition demands an overhaul of the entire delivery system, from the power plant to the utility pole.